Hi everyone, welcome to our workshop session about implementing skills. And we see that people already write in the chat that they have their Claude open. So before we start, I want to clarify what we are going to actually do during this workshop. I'm going to now open the workshop. I'm going to send you the link to the workshop. It's going to be here in the live chat, so please open it. So it's good that you have Claude open, because what we are going to do today is we are going to re-implement some of the functionality that exists in code and in other AI agents, but we're not really going to use Claude today. So let me also instruct my code to commit the code. I think it's doing something not good. Okay, I don't know what it's doing. Anyways, so I'm going to share my screen right now with you. Because in the workshop link that I sent you, it's a bit drafty version. So I asked Claude to polish it before publishing it. And I think it's going to destroy my README, but we will see this later. Okay, somebody's note taker is requesting to record the meeting, but we're recording the meeting, so don't worry. And you will get access to everything that I share here today. So I already shared this link. So what we're going to do today is we are going to implement the functionality of skills and commands that exist in Claude Code, but we are going to create our own agent that has these capabilities. And maybe you know about skills, but I want to start today. I want to start by talking about the skills. So I'm going to create a new. So I'm going to create a new folder. What called skills? Oh, sorry. TP. Okay. So what I want to do now is I want to illustrate the concept of skills. I'm going to open it with Visual Studio Code. And I'm going to open my Claude. Or maybe before I open the Claude, I want to show you what skills is. We are actually going to cover skills and commands. So both are ways to reuse the functionality, the prompts you wrote, the instructions for the agents. And I want to start with doing a demo. So in this demo, I want to get some data from GitHub. So some time ago, I was playing with Claude Code, and I created these two commands. So the first command is called /kit, and the other command is called /parent. So when we run /kit, so this is the instructions for the kit, the kit needs to come up with a wild idea, and then the parent implements this idea. So the parent is the programmer, the developer. The kit is just a kit with wild imagination. So the kit comes up with crazy ideas, and the parent is implementing them. So this code right now is stored in my GitHub repo. So what I want to do is I want my agent to go to this GitHub repo and pull these files, download these files. So for that, I want to create a skill, which I will call GitHub fetch. So this is the skill. And I'll create a demo here. So in this demo, this is where we're going to do this demonstration of Claude Code. So I'm going to download this skill. We'll see. We'll take a look at the skill now together. So this is how the skill looks like. So the skill is a description of how to achieve something, and this is reusable. So the goal we have right now is we have some files on GitHub, and we want to use the command line gh. This is a CLI from GitHub that allows us to download things from GitHub. So here in these instructions, in this skill, we describe how exactly we can use the GitHub CLI to do what we want. So if you want to list all the content in the repo, this is how you do this. If you want to list subdirectories, this is how you do this. If you want to get content, this is how you do this. So the agent doesn't need to figure this out by itself. We already give it instructions of how to do something. So, and then in Claude Code, we typically need to do this in Claude Skills folder. And then we create a folder that we call gh-fetch. And then inside this folder, we have a file that we call skill all caps. And then we can have some extra files there. But this is basically the structure. So now when I have this Claude, so now I execute Claude, and I want to ask it get this kit and parent commands from here. You don't need to redo this if you don't have Claude Code. It's fine. So here I just want to show you the concept, right? So this is what we are going to implement today. So this is just a demo. You don't have to follow. If you want, you can, but you don't have to. So right now, Claude Code is asking if I want to. It discovers this skill. It sees that this skill is actually relevant for my request, and I say yes, you can. You can use the skill. So I allow it to read the skill. So now what it's doing, it's reading the content of the skill, so which is a Markdown file, and now it understands how it can achieve what I ask it to do. And I say, yeah. So, but I think I can just let it run and do things. Well, let's see what it asks. So at the end, what I want it to do is download all the commands. Maybe I just don't ask it again. So I just want to let it download all the commands here. Yeah. So we will see here skills. Oh no, it hasn't successfully put the content there. I don't know why, but eventually it will get there. Okay, yes, please do this. I think this is maybe an example of when it's. Oh, here we have kit parent. Okay, so it has downloaded these files using this skill. So this is the idea behind a skill. So we already have some knowledge. We know how to do certain things, think in the best way. And instead of telling the agent what exactly to do, we can just put this thing inside the skill and then reuse it across our projects. And then the commands are kind of similar, but the difference between commands and skills is now I need to exit Claude and continue. So I do Claude -C to continue the session. The reason I did this is because for it to discover the commands, I need to restart it. And now I can just run the kit command. And here I am being explicit. So I say, here's the command I want to execute. So I just say, this is the command, please go ahead and do this. Right? So this is the difference between the skill and the command. Command is, I know what I want to do, and I just tell it execute it. So execute the command kit, right? And skill is something that the agent needs to decide to invoke, right? So this is the difference. So in the first case, it's implicit, and the second case, it's explicit. So the kit came up with the idea, sneeze simulator, and then now I can do parent, and the parent will implement the sneeze simulator. I guess it's entertaining, right? Because the ideas are often crazy. So when I was preparing for this workshop, the kit created a lazy to-do list. So every time you add something to the to-do list, the program is taking some time to add something. So it's funny. We don't need to wait. I think you got the point. You got the idea what the commands are and what the skills are. So what we did here, we used the skill to fetch files from GitHub, and these files just happen to be commands, right? Okay, I think the parent is now creating the sneeze simulator. We can see it here. Okay, can I try to run it? Just out of curiosity to see what is actually there. Okay, entertaining. Let me stop it. So right now, I asked it also in the parent command. I asked it to test the thing, but that's not the point. I just wanted to show you what the skills are. Right. So this is now what we're going to do. We're going to implement the skills ourselves. And for that, I don't know how many of you attended my previous workshops. In one of these workshops, there should be a link somewhere here at the beginning. This create a coding agent. In this workshop, we created a coding agent. So I will show you a quick demo. If you attended this workshop, it's great. You have the materials on which we're going to build. If not, I'm going to do a quick recap. So it's fine, right? And then you can later, because the link is here, not here. The link is here. You can always just go through the materials later. But I want to quickly show you this video. So this is what we implemented in this workshop. So we created a coding agent that can take a Django website template and implement whatever we want on top of this. So this is how it looked. So we give it some instructions. Oh, I think I spoiler. So here we give it some instructions and we give a template, an empty project, an empty Django project, and we say, okay, agent, we want to implement a to-do list. And then the agent analyzes the current structure of the project, and then it uses different tools. We will go through these tools. And yeah, right now we can see that it's doing some investigation, and then it's writing the code, it's creating the code, and then at the end, so now we can see what it created. So this is what we implemented. So an agent that it can implement a Django website. In this case, it was a to-do list. So I think it's 2x, if not more, right? So then this is what we implemented. What we are going to do today is we are going to take the agent we implemented, but instead of making it Django specific, we're going to make it general purpose. So it's going to be an agent that can do, well, it's like basically Cloud Code that can execute any user request. And we will give skills and commands to this agent. So in order to understand how the skills and commands work, the best way to do this is to implement them ourselves. So this is what we are going to do today. And let's start. So I'm going to start with preparing the environment. So I already created the folder. If you don't have UV, you need to install this. So this is the thing we are going to use for dependency management. I already have UV, so I'm going to go ahead and write UV init to create an empty project. And then I also am going to install some dependencies. So in this particular case, we need these 4 dependencies. Jupyter, this is the environment that we are going to use for executing our code. OpenAI for communicating with, instead of OpenAI, it can be any other provider, but I'm going to use OpenAI. ToAI-Kit is the framework I use for creating agents. And then Python front matter, this is the library we are going to use to parse these skills and commands. Okay. So then also we need to configure our OpenAI key. So what I'm going to do now when it stops installing, I'm going to create a file that I already have that contains the OpenAI key. I'm going to just copy it from there to here. And then I have this tool called ditter.env that automatically loads whatever. If I have env or env-rc file in my environment, it automatically loads the environment variables from there. So I also describe how to install this library if you want here. But I have this library that loads it, and now it's important to make sure I don't accidentally commit this file to Git, so I don't want to accidentally expose my OpenAI key. That's why I'm going to add this to git ignore. So in my case, it's env-rc. So that's why I'm going to, so if I do git init and git status, I don't see the this env-rc file, right? So I will not accidentally commit it to Git. And yeah, good practice. And now we start the notebook. And when I start the notebook, I already have this OpenAI API key as environment variable. So when I start it, Jupyter Notebook should have access to it. We will now test that everything works when it finally starts. It's taking some time. I think I might already have Jupyter running, so let me check. Yeah, so we'll stop it. Okay, and right now I'm going to just create a new notebook. Okay, why it's blocked? Okay, whatever. Untitled, I'll call it notebook. Right, and then the first thing I want to do is I want to test that my OpenAI API key works. OpenAI, import OpenAI client. So now if I can execute this line, it means that my key is configured correctly. So I think since we just started the notebook, it's taken some time to, yeah, okay. So things work, cool. And so what do we do next? So next I want to do a quick recap. So here I assume that you already know what an agent is. So I'm not going to go into details of what an agent is, how they work. For that, I hosted 2 other workshops. One was specifically an introduction to agents. You can check it here. Another one was creating a coding agent, where I also explained how agents are created and what is inside. But just for the sake of completeness, I want to do a quick recap. So agent consists of multiple components. So an agent, we can think is something that we give it requests, we users give it requests, and it executes these requests. So, and then it decides how to react to our requests using an LLM. LLM is something we typically so this is an AI model. So this is typically, we use OpenAI or Anthropic or Grok or whatever provider for that. So typically we just send a request somewhere and then we get a response from there. So this is the brain of our agent. Then we control we give this agent instructions of how it should behave, how it should react to our inputs, right? So these are the instructions or system prompts. Then the agent has access to tools. So with tools, it can interact with the environment around us. So in our case, the tools that we're going to use are read file, write file, execute a bash command, do grep search, or look at the file tree. So these are the basic commands that our agent has access to. But in general, any agent has some tools. This is how the agent is interacting with the environment. And then agents have memory. So this is simply a message history of what we actually sent to the LLM provider. And yeah, here's an example. So we give instructions, fix the bug in this file. So the agent is analyzing this file. It finds the issue, then it fixes the issue, and then it runs the test, and then it reports that the issue is fixed. So this is a simple, what we call an agentic loop or tool call loop. We give it some instructions, and then it invokes tools to implement the user request until everything is fixed, and then it replies with done, right? And the tools that, in our case, we are going to give the agent are these ones. So the tools are read file, write file to file, see the file tree. So this is basically the same as executing here, executing tree command. If it works. Well, basically, so for the agent to know what we actually have, right? And then execute bash command. Of course, we want it to execute things, and then search its files is like grep. Okay, so, and we already implemented this in the previous workshop, the coding agent. This is where I showed you this to-do tool, the Django tool. So these are, this is the implementation of the tool, of these tools, right? So this is how read file is implemented. This is how write file is implemented. So this is a fairly simple implementation. The only thing that is maybe different is that this is specific to Django. We don't allow it to execute some commands, right? Run server is not allowed. But for us, it's not important. Okay, so what we're going to do is we are just going to get these tools and we are going to use them as is. So I have this command, then I'm going to execute. So now here we have these tools. So this is what I just downloaded. And now we are going to create our agent. And we will start with creating the folder. So this is where our agent will operate. So I'll call it test project. So this is an empty folder. So when you use Claude, so here I have Claude, right? No, I closed it, but I run Claude in this directory, in this demo. So this is the current directory for Claude, right? And this is here. This is where we kind of run our agent. So this is the current directory. Right now it's empty, but we're going to put some things there. Okay, and now we're going to test our tools. So we're going to, so they all are, these tools are inside the tools module, agent tools class. And we can see that right now there is nothing. So the tools that we have, C file tree and then write file. So if we do write file echo txt hello, then when we open it, we can see this file here, right? So this is a simple set of tools for interacting with the file system plus executing the bash command. So this is what our agent is going to be able to use. I'm going to clean it a little bit. So this is our tools. And we are going to use a library for implementing agents called Toy AI Kit. So you can read more about this library here. I have implemented this library, and I'm going to share the link with you. And I see that there are some questions that I didn't notice. I'll answer them later. So the idea behind this Toy AI Kit is just something I use for teaching, for showing the concepts, for illustrating concepts, because it's very interactive. But this is not a production level library that you should use for implementing agents. So we implemented this library together. There was a workshop where I showed how to implement certain things, and then this at the end resulted in a library. I think there are some links here if you're interested. But I'm going to use this library. I would also encourage you to try this library, but this is not something you would use in production. In production, you would use something like, my favorite one is Pedantic AI, but there are many other libraries, agentic libraries that you can use. I recommend this one, but at the end, they are very similar. But today we're going to use Toy AI Kit because it's very interactive and we can see what the agent is doing and we can interact with the agent from the command line. But all the tools that we have here, they are easily portable to any other framework, and all the approaches that we discuss here, they are portable to any other framework too. Okay, but I'm going to now create this tools object from Toy AI Kit, and this is a wrapper for all the tools. So if I do now tools object get tools, we will see, yeah, my Jupyter is taking some time to do imports. But when I do get object, so it returns the tools in OpenAI format. So this is how OpenAI expects us to define functions that it can execute, that the agent can execute. And we can see that all the functions we have in the in our tools file, they are here. Right, so it can automatically discover it, but also all other frameworks like Pedantica can also automatically automatically load things like that. Okay, so we have our tools. We now need to implement our agent. So for the agent, in the previous workshop where we implemented the coding agent for Django, so we can you please? No, I guess it cannot do this. Developer prompt, system prompt. So I'm looking for line 300 something. Well, there is a prompt somewhere here, right? So maybe it's not really important what the prompt is. Here it is. So you're a coding agent. Your task is to modify the provided Django template according to user instructions. Right. So this is very, very Django specific. We say what there is already in this folder and what it needs to do, like describe the file. We give some additional instructions. So this is very Django specific. But in this workshop today, we're going to implement a general purpose agent. So we need to give it a general purpose instructions. And actually, I forgot to mention at the beginning of this workshop is everything I talk about here today is based on the implementation of OpenCode. So I analyzed how OpenCode works because Cloud Code is closed source. I cannot really analyze the code. I cannot really see the code, and we have some ideas of how things are implemented there, but at the end we don't have access to the source code. But OpenCode is an open source implementation of Cloud Code. So the idea is very similar. It's a CLI coding agent, and it has it's open, so it's fully open source, right? And so what I did is I analyzed how skills and commands work there, and based on that, we are going to implement them today ourselves. And in this open code, this is the prompt they have. So this is the prompt, the system prompt the agent has. And the prompt is you are open code, the best coding agent on the planet. I guess it's good to add things like that. And they basically describe what is expected of this agent, what it should do. This is a pretty comprehensive prompt. And I thought again, like this is, we don't necessarily need it today because it's a pretty big and comprehensive. And so at the end, I came up with a smaller prompt. Well, by I mean, of course, I asked an AI assistant to just condense this prompt into something smaller. So this is what we are going to use today, right? So this is the instructions we are going to give to our coding agent. You are a coding agent designed to help with software engineering tasks. Maybe I should have added that you are the best agent in the world. I don't know if it helps with self-confidence, maybe. And yeah, here you help user with, and your task is to use available tools to satisfy the request from the user. So this is a pretty simple, straightforward instruction. So I took, as I said, I took this instruction and I simplified, and then at the end we ended up with this. Right? So this is going to be the system prompt for our coding agent. And now, yeah, I need to do a few boilerplate stuff to actually create our agent. So we already imported OpenAI, right? So now I need to create a wrapper from AI Kit so I can use it. And here, so agents in AI Kit, I use runners because agent is, to me, it's a bit fancy, a fancy word. But what these agents and runners are doing, they're just executing a while loop, right? That's why I just called it runner. So what this runner has is it has access to these tools. This is the tools object we created. It we also give it these instructions, this system prompt. Then we have the client. This is how our runner is going to interact with the model. And here I think we also can specify model GPT for all. I'm going to use a simple model. And this is going to be a toy implementation, right? So you shouldn't expect anything like spectacular and super serious from this implementation. Our goal is to understand how these things work, so we can first of all learn how to, when we design agents, when we create agents ourselves, we can get some inspiration and perhaps use some of these ideas for our own agents. And second is when we use these tools in coding agents such as Claude Code, we understand how these things work so we can use them better, right? So for that, for O-mini is enough. But of course, if you want to have better quality, you should go with 5.2 perhaps, or with Anthropic Claude Sonnet, at least like maybe 4, Sonnet 4. Anyways, so I'm going to use a simple model here. So here is the runner, and I'm going to do runner run. And right now, this is the reason why I prefer to use Toy AI Kit in workshops, because we get this this interface, this interactive interface. And I can say implement, I think I'll just copy the prompt that I have. Create a Python script for calculating the sum of all numbers passed as input. So this is, we're not going to implement like Amazon.com from scratch or Facebook. We're going to do something very simple. We just want to create a script that calculates all the numbers that we pass to a script. Okay, so the agent is thinking. So right now it says, okay, I'll create a simple Python script. Then it says, yeah, so it did create some numbers with this content. You can actually see it here, some numbers. So this is the content. It's fairly simple. And then I can ask it to run it, please. So now it's using this tool execute bash command to run this, and then it reports back the result. And then at the end, now I want to stop this. So this is why I like using Toy AI Kit, because I see all the function calls, all the tool calls, right? I see what exactly is there. And I have this kind of chat interface where I can interact with the agent without leaving my Jupyter notebook. So I don't need to create any Streamlit application or anything like that. So I find it pretty convenient. But at the end, as I said, you can just migrate easily to Pydantic AI or anything you want. So you just take these instructions, you take these tools, and then in Pydantic AI, you say, hey, like, I want to use OpenAI GPT-4o mini, and that's it. The rest will work in the same way. But this is our agent. This is the very simple agent that we just created. It doesn't have any tools yet, right? Or it doesn't have, sorry, any skills yet. So now, this is why we are all here today, because we want to implement skills in this agent. So now let's do that. And I forgot to mention that we can see how much we paid for executing this. So what we paid is, this is in dollars, right? So we've paid very little. That's good. That's encouraging. That's why I like GPT-4o mini, because it's almost free. You just need to have some money on your account, and then you can run your agents forever. Of course, they will be not the best agents, but for testing and experimenting with things, it's very good. Okay, let's continue. So now we want to create a skill. So I already have skills. Yeah, I don't have them here. Maybe I will need to copy them. But in the folder, so in this folder, sorry, I'm jumping back and forth. So in this agent skills, this is the workshop folder. We have the skills folder with 5 skills. So what I want to do now is I want to copy the skills to our folder, so then we can use them. So I'm going to do cp -r, so they are here in workshops, agent skills. I'm going to copy here. Okay, so now I have this folder skills here. This is what we have. And then I have a skill called hello. This is a very stupid skill just for illustration. So every time user says hi, we want to respond with an emoji, right? So we want to be polite. So that's the skill. So I don't know how useful it is, but let's try to add the skill. But by the way, this is how skills look like, right? So we have name, we have the description, and we have the content. And I have more complex examples, right? So here we have actually some scripts inside. So this is a skill that explain something, and then it says there is some bash command that you run. So the skills can be pretty complex at the end, right? So we're not going to touch this coding standard skill. We're not going to touch this deploy app skill, which are complex things with some scripts. This is for you just to maybe get some ideas of what can be done there, right? But for us, yeah, all we care about is, and in this workshop we are going to implement, is a simple agent that all it can do is just get access to this skill file. But when we use Claude Code or OpenCode or any other AI agent that supports skills, they would, of course, also load other files. And I will also include actually a reference implementation that is based on OpenCode, that is in Python, that can read that can do all these things. I need to commit it, but you'll find it in the same repo as this workshop in the folder called prototype. Okay, but what we want to do is we want to implement this simple skill, hello. Okay, so how do we do this? I'm going to close this. How are we going to do this? So first, I want to create a simple data class that will hold the data. So I'll call it skill. It has name, it has the description, it has content. In case when we talk about Claude Code or when we talk about the reference implementation, right? In addition to name and description, they have other things. They have license, they have Skills.md. So as you can see, many already platforms implement this. So I think they have some reference name, description. I think they have some other things, but basically these ones are the most important ones. That's why we only focus on them, right? Name, description, and content is what we actually have here. So these two are mandatory. The rest we simply ignore. And yeah, here, this is the content. Okay. And to read this, so this is called front matter, right? So there's some structured part, YAML, and this is unstructured part, Markdown. So this is called front matter, and we're going to use library called front matter, which we installed already. That yeah, it's going to parse. So this is how we are going to do this. So I'll do this step by step. So actually, let me check if this is right. So here we have skills. So it's 2 levels up. Skills. What? Sorry. Just want to make sure I am in the right place. Yeah, I think I have skills here, so I don't need to go 2 levels up. Sorry. Okay, so skills directory, we have it here. And then let's say we are interested in hello. Name is going to be hello. So then this is going to be our skill file. right? So skills, hello, skill.md. So this is always the structure, the name of the skill, then the main file, and then the rest loaded on demand. And what we do is we use this front matter load to load this file, right? And then here we have some metadata. This is the front matter, and we have content, which is the content, right? So this is fairly straightforward. So we just load this using front matter, and then we wrap it around the data object. So fairly straightforward. So the way we use it, load skill, hello. So it just loads the file, right? So nothing fancy. And then the next thing we want to do is we want to iterate all the skills we have. So I'm not going to implement it line by line, but the idea is quite simple, right? So we just iterate over the things in the directory. If it's not a directory, we don't care. But then if it's a directory, we load something from there. And yeah, here we don't do any error handling. So we just expect that if it's a folder, it always has the skill file inside, right? Of course, in real life, we want to add some error handling. And we can see that we have this coding standard, we have counter, we have deploy app, we have joke, and we have hello. These are the skills we have. And now I want to put this all inside a class, because like having these files is not really convenient. So what I want to do is I just want to have this class called skill loader that we initialize with the folder, the path to the directory with skills, and then we have this load skill, we have list skills, and then we have this get description function that I'll illustrate, that I will show right now. Right, so skill loader, and then we will use it for this skills directory. And then what this description is doing is just printable version of all the skills we have. And here you can notice when we do get description, what we load is the name of the skill and the description of the skill. And also what is important, but we don't really check it here, there is some limits on how long the description could be. And the reason is for that is we want to preserve safe tokens, right? So because when our agent starts, we want to include everything we have in the system prompt, right? And when we send our message with the system prompt, our tokens are consumed, and then at the end it becomes more expensive. So the longer the system prompt, the more expensive, the more we have to pay, right? So then we don't want to send the entire skill to our agent yet. We only want this agent to load the skills on demand. So we here have the description of the skills, and if the agent thinks that it needs now to read the hello skill, then it will get access to the skill. And the way it works, the way it's implemented is using the tool call. So we'll have a tool. So we already have some tools, tool for for reading a file, tool for writing a file, tool for executing a bash command. In the same way, we will have a tool for reading a skill. Right? So this is how it's implemented in Cloud Code, in Open Code, and in other providers. It's implemented through a tool call. So the agent, when I send it a request and I say, hey, can you please greet me? It will understand that I'm talking about greeting, and then there is a special skill that is related to greetings. And then, because it says, okay, there is a skill available, let me check, let me look inside. And then only when I ask for it, it loads it. So this is the mechanism behind skills, behind lazy loading of skills. And the idea here is that the agent decides when to load the skill. So let's implement that. So for that, we also need something that looks okay, so I think I want to show you this. So we want something that looks like this. So we want tools, a class for tools with init method and the tools. So in our case, it will be a simple class. I'll call it skills tool, right? Yeah, skills tool. And this is a simple wrapper for the skill loader. So it has only one tool, which we call skill. And what the tool is doing, it's loading a skill to get specialized instructions. And then inside, internally, it uses the skill loader load skill, right? So now if I create skills tool, skills tool, skills loader, and then I do skills tool skill hello, it loads the hello skill, right? So this is, we're not going to do this manually, of course, our agent is going to do this. So now we just need to let agent know that this tool exists. And we have this tools object, and we just add it to the list of tools. Right, so when we get tools, now we have, in addition to all the previous tools we had, like executing a bash command, now we also have this tool called skill, which loads a skill to get specialized instructions. Right. So where is our agent? So this is our agent. So now, if I just run this agent, so I'll just do this. Hello. So it doesn't invoke any tools, right? So it doesn't invoke any skills. So what we want to see now is we want the agent to automatically understand, okay, first I'm greeting the agent, so it needs to load the skill that is related to greeting. So what we want to see here is the agent loading the skill, reading the file, and then responding according to the instructions in the file. So this is not happening. And the reason it's not happening is our agent doesn't really need what kind of skills it has. So it needs to have access to the skills, to the list of skills. So it needs access to this thing, right? It needs to know what is there. The way it's implemented in open code is it's injected, the list of skills is injected in these instructions, right? So here we have the skill, and this is the instruction that when we do tools call get tools. So this is this thing. We have the description, and this is the doc string, right? So what's happening inside open code is that this list, or with all the skills, all the available skills, is injected here in this description. So when we send the request to OpenAI, we send all the, or whatever provider, in the payload we send all the list of all the tools we have, including the skills, and the skills tool has the description with all the skills. So in our case, it's a little tricky to implement. So first we need to figure out how to add this to doc strings. Another thing is, in my experiments, even though I found out how to do this thanks to Claude Code, at the end, it wasn't as effective as a simpler method. And this is what we're going to implement. So instead of including it here, we are going to modify this prompt. So we have these agent instructions, and what I want to do here is I want to include the list of skills here in the prompt, and this will be dynamic. So we will not hard code this, of course. It will be dynamically generated. And this way, our agent will find out about the skills we have. Okay, so let's do that. So for that, I will have this skill injection prompt. And this will basically, let me print it. It will look like that. You have the following skills available, which you can load with the skills tool, and then the list. So what we are going to do is we are going to just append this at the end of these instructions. right? And then when we create our agent, it will have the instructions, and inside these instructions, we will inject the list of tools. So then this is the new instructions, agent with skills instructions, which will look like that, right? So everything we had before plus the list of skills. Okay, and because it's in the list of skills now, the agent will know how to actually, what actually to invoke. So maybe what I will do now is I will change it to agent with skills instructions. And now I say hello. And we see that now it reads the skill. Hello, it gets the instructions of what it needs to do and says, hello, welcome, how can I help you today? And then we see the emoji. Well, that's the whole reason why we were creating the skill, because when we say hello to the agent, we wanted it to reply with an emoji. Amazing use of GPUs, I guess. Anyways, but we can see that it works. So the skill is invoked. Yeah, so this is cool, right? So this is how, even though it's a very simplified version of the actual skill implementation, because as I said, the real skills are a little bit more complicated. Because yes, you can go quite far with just using the Skill.md, but also it's very useful when there are some things that you can run to. Like for example, instead of including the bash script here in the skill so that the agent has to create and write it somewhere, the agent can just execute a bash script that already exists inside the scripts, inside the skills folder, right? So this is very convenient. Well, maybe actually it would just run, but right now we don't have any logic for turning this app to the full path, right? So in case of Cloud Code, it would actually, or Open Code. So I think Cloud Code would just read this immediately, but Open Code would, at least based on what I saw in the implementation, when we include this add in skills, so then it knows that it's kind of relative to the skill folder, right? So then it can create the whole path. Okay, so now I'm going to continue and implement commands. But before I do this, I see that there is some activity in the chat. So I want to check. I want to check what is happening there. Are you going to share the recording with us later? Yes, the recording is going to be shared. Actually, this link that I gave you, that I shared with you at the very beginning, this workshop, I am going to include the link to the video at the beginning of this workshop. How do you figure out what to add into skills versus what is already part of the model knowledge base? So most of the things are already a part of the model knowledge base, but it doesn't mean that what the model is doing is the most effective way. The way I create skills is I have Cloud Code here, right? Is it running? Okay, it's running. So I'm interacting with Cloud Code, and then often I steer it in a way I want, right? So I see it's doing something, and then I say, okay, no, like take a slightly different approach. And then at the end, we both arrive at the destination where I wanted to go, but the agent does not necessarily know the way I want to go there, right? So I have to instruct it. And in order to save time, I don't want to instruct it the next time we do this. So the next time I ask the agent to do something, I don't want to explain again what exactly I mean, right? And then what I can do is I can put all this knowledge, what we did together, inside a skill. And typically when in projects, I already have some skills in my projects, and then I can just ask Cloud Code, hey, can you please create a new skill based on the skills that we already have? And put everything that we did together right now inside the skill. And first of all, it's kind of lazy. I just give it, hey, like whatever we did, put it there. And this is how to say, reproducibility or knowledge saving. So next time it will basically save me a lot of time. I will not have to tell it what exactly to do because it's already recorded, right? So it just reads the MD file and that's it. And I have very nice, I have an example, or I don't know how nice it is, you'll be the judge, but it's convenient for me. For running courses, I use this website, right? So this is our course management platform. And typically, in order to do something, I need to go to admin panel, and then, I don't know, maybe to courses. And then I need to, homeworks. And I need to create a homework, so I need to click things. I don't know how much internal information I'm showing you that I'm not supposed to show, but I think it's pretty safe. So I need to click here. I need to fill this all in, right? And then when I put questions for homework, I need to click here, here, here. So that's a lot of clicking. But what I also have since recently, or maybe a few weeks, maybe even less. So there is also an API. And by the way, this actually code for this thing is open source. If you're curious, all the code is here. So for a week probably, there is an API that actually allows me to interact with this system. So I don't need to go there to the admin panel and click, 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 click. Now I can just send a JSON request with everything I need, and then it would create, so I recently used it to create this, right? So it would create all the homeworks, it would create all the projects in one request. Right? That's very convenient, right? But then how do I create this JSON request? Right? And this is where skills help. So for that, I have this skills that course content that I basically describe how it should interact with the API. So this website has the API, and I just describe how to do this and how it looks like. And also, there is no way this model would know these things, right? So first time we just I was just instructing the model what to do, and then I said, hey, now let's save everything into skill, and then we iterated a few times. And then now when I need to do something like that, what I can do is I can also just use this dictation function. So what I can do is I can just dictate the instructions to my Cloud Code. And when I finish, I just hit enter and then it's everything. That is very convenient if you ask me. So I'm going to execute that. But I think the answer was maybe longer than necessary, but I hope it was useful. Latest version of Cloud Code can hot load commands, no? I don't know what exactly you mean by that, but so what I can do is I can ask it to invoke a command like that, or I can say invoke git, and then invoke parent. And then in both cases, so in the first case, it will just simply inject the command, and this is what we are actually going to do right now. So the way it works is just simply injects the command into the prompt and then executes this. And when I do something like that, it actually uses a tool to load the command and adds this to the message history. And this is how we are going to implement this today. So we are also going to implement commands through tools. So by now, it's pretty similar. And I think actually with what we already covered in this workshop, if I stop now and ask you to implement these commands, you should be able to do this because basically it's more or less the same. And I'll still do this. We will see how to do this. Yeah. So let's see what else we have. Where did the skill instruction get executed? I think it was locally by the runner. So where did the skill instruction get executed? So let's take a look at this. So here we greet the agent, right? And then in the instructions you have the following skills available, which you can load with the skill tool, right? And then if I look at the whole thing, The instructions are, you have the following skills available, which you can load. And we say, hello, skills for all greeting requests. So the agent understands that this is a greeting request, and it knows that it needs to use the skills tool to invoke this tool with this parameter, with the parameter hello. Right? Then what is happening is it says, I want to execute this, and then our computer, Jupyter, execute this. So it's actually running this tool. So we have this skills tool, right? We have this skill, hello. This is running it. And then it's adding to the message history. Right, so then if this gets added to the message history, we can see the message history here, maybe result. Let me show it to you one more time. Hello. Stop. So now we can look at the result, and we have messages. Oops, I don't think it's okay. So this is what was happening. So the first thing we have in our history is the system prompt. You're decoding agent designed to help with blah blah blah. Then second one is our input that we did here, input. So this is the system prompt, developer prompt, and this is the user prompt, right? Hello. And then based on what the agent received, based on what the LLM received, it's so okay. Now I need to execute this tool called skill with the arguments hello. And then we execute it on our end, and we add this to the history, and we send it back to the LLM. And the LLM sees the whole thing, this whole thing, and sees, okay, there was a request, then we decided to invoke the tool, and now I have the instructions of what to do with this, and then it replies with the emoji. So this is what was happening. I don't know if the question was about that, but yeah, so it was executed locally. Where do you draw the line between skills and tools? So for me, this is, we don't explicitly ask it to use a skill, right? So then the agent figures it out automatically that, okay, it looks like a situation where I can use a skill, so let me use it. And command is more explicit. So you want to execute the command, right? So you want to execute the command kit, right? You don't ask, hey, like, so I'm trying to think of a good example. So in one case, it's kind of implicit. So the agent thinks, okay, now I know what to do. And instead of, figuring it out myself, I just load the skill. And the command is, you just have to do this way, right? So it's not optional. I don't know if it helps, but this is how I see it, right? So as the user, I have to write git here. While here, when I write hello, I don't mention any comments. I might not even know that there are some skills that make the agent greet me with an emoji. Which models support using skills? Are there any prerequisites for these models? So if a model supports tool calls, then the model supports skills. And most of the models we have these days, they support tool calls. I don't know about open source models. I think even smaller models these days, they support tool calls. So as long as there is tool call support, then you can do skills. So basically, we've converted some instructions from skill specification format into a Python-based tool, which is executed locally like traditional tool calling. Exactly. So this is nothing else but traditional tool calling. Here, the beauty of it is that it's lazy loading, right? And the lazy loading in this case is we don't inject the entire skills directory in our prompt. We only inject the name and the description, right? We say, hey, like, by the way, there are these skills that are available, up to you if you want to use them or not, right? So, and then the skills are loaded on request. So that's the beauty of this mechanism, right? So it helps to manage context this case, so we don't spend too many tokens. Any limitations or do's and don'ts for skills? I don't know about don'ts. For do's, I think I described you the scenario how I use the skills. So typically for me, I already interact with the agent, and then I need to steer it in the right direction. I need to tell it, hey, like do it differently, or please use this tool. Yeah, and when I want to, I know that next time I'll need to do something similar, I save this. So I ask agent to save this as a skill. I review it. I asked the agent to add more stuff if I want, and then eventually it becomes something like this, right? So I also often manually edit, and by manually editing this, I may say I just like remove some parts and say, hey, like this part was not necessary, or yeah, things like that. So, and you can see it's actually pretty detailed, but yeah, it's only used here. We have the description. Get or add homeworks and projects to courses via API using curl. So when the agent sees the request that I want to add homeworks and projects, it knows how to. It knows that okay, I need to load the skill. Are Claude models fine-tuned to use skills better, or there is anything going on behind the scenes with Claude skills that we might not be doing? So I cannot answer these questions because their models are closed sourced. Claude code is also, well, the models are closed in general. Then the Claude code is closed. It's obfuscated. So like even though, yes, we can have it's not binary, it's minified JavaScript, but you cannot really make any sense from it. Although actually maybe if I ask Claude Code to reverse engineer Claude Code, I don't know how successful it will be. Maybe we will be able to understand some things. At least I know people were able to retrieve the prompts from Claude. But I think, I don't know if they actually do fine tuning. So what they may do fine tuning for is tool call, right? So this is the important part here. If the model is very good at calling tools, then it should be able to use skills because the skills are implemented through tool calling. But I don't know if there is anything going on behind the scenes that we might not know. For me, as I said, for when I was preparing for this workshop, I was using OpenCode. So this is open source. I downloaded the source code and I used an AI system to figure out what's happening. So it's written in JavaScript. My JavaScript is rusty. That's why, I was mostly relying on the agent, but then I was also checking the code myself. And so, if you want to figure out some things, I would actually recommend this code as reference. Have you seen 100% conformance to skill steps being executed? I didn't run any benchmarks. To me, it feels like when I want skills to be executed, they are usually executed. But yeah, this is just anecdotal. I haven't run any benchmarks. Which minimum LLM works best with these open skills? Well, I would call GPT-4o mini quite minimal. Yeah, somebody has questions?
I should be on a 6 and see what it says. I'm curious now.
Can you say it again? Or maybe just mute yourself. Okay. Okay, I muted you. So I don't know if it was on purpose or not. And if you want to ask a question, maybe just ask again. I just didn't understand the question, sorry. But we still have other things, right? We still have 20 minutes. And I wanted to execute, to do the commands. As I said, it's pretty much the same. We already have done this. With commands, as I said, this is very explicit. So the command has to be executed. So when the user says /git, we have to execute this call, the tool, so that there is no other way. So there are two ways of implementing this. So the one way is when you, so I don't know, when we are processing the input, we see that something starts with the comment, right? So when we do it here, we see something starts with the comment. What we do is we intercept this, we overwrite this by replacing /kit with the content of this of the comment, right? And then we just send this as a request as input to the LLM. That's one way of doing this. And according to my discussion with Claude Code about open code implementation, this is how it's implemented. And there is another way of implementing this is through a tool call. So when we have something like execute kit and then execute parent. So in this case, it's actually two /commands followed one by another. And in this case, we actually have to use a tool call, right? So the agent will understand what we want to do. So then it will invoke the one tool, then it will wait for the output, and then it will invoke the other tool. Right. So what we're going to do is we're going to follow the second path because it's simpler to implement. In case of the first option, we would need to actually be able to modify the code here. So yeah, this is not something I want to do during this workshop. But if you're actually going to implement something like that in your own projects, probably you will need to implement this functionality yourself. We're going to follow the simpler way through a tool call. And yeah, again, for this, I'm going to, sorry. So I'm going to reuse these commands that we have, kit and parent. Yeah, so I'm going to create commands folder and then download these things here. Where's my Claude Code? So then I have commands, kit and parent. If you use Claude Code, of course, all this goes to .claude, right? Like we saw this in the demo. We have commands and skills, right? In case of open code, I don't remember. Yeah, open code or Claude, so they're usually compatible. Okay, so we already have these things, and then we just follow the same approach. Actually, we don't need to do much. So we have name, description. So in this case, name comes from the name of the file, right? So previously, name was defined inside. It was defined inside this Markdown file, but here is the file name. Then this description is everything that is inside. Or sorry, this is the thing in the front matter. Here, the description, right? And then the rest is what is inside. So here we call it template, and this is how it's called inside open code. Because also inside this, if I open, so here we can have some parameters like this arguments. And what happens is when we have some arguments, we want to override the content of this file with these arguments. So I'll show you how to do this, how these agents do this, but we're not going to focus it. So we're going to keep it very simple. We're just going to focus on conceptual understanding. And yeah, which means we're just simply going to load these files without doing any pre-processing or post-processing. So this is our command loader. It's very similar to skills loader. We have this load command method and list commands method, right? So then command loader. So yeah, the logic is the same, right? So we say all our commands are in this folder, and then we can load command called kit or parent. Right? So then this is our command loader, and then we also wrap it inside. We wrap it inside a class for tool calling. So in this case, the tool is called execute command, and then this is instruction execute a command by name and return the rendered prompt. if you see input starting with command, then use this tool. And I thought I have examples here. So examples could be examples. So it could be deploy, execute command name deploy, right? And then test, execute command name test, something like that. And so we want to explain how to actually react to these slash commands, right? So we want to make it apparent that it starts with slash. Yeah, but also the command name without the prefix. So here I'm doing a bit of post-processing. So the agent, especially the tool, the models, especially this GPT 4.0 mini, they're not the smartest model. Sometimes they may still include the slash. So that's why I'm removing the slash here. And then this process template, I was talking about these arguments, 1, 2, 3 arguments. So I'm not going to process to do anything, but if you want, this is where you do this. Right, so you turn the template into an actual rendered command here. And let me actually do this. So you wrap the command loader into this commands tool, and then this is how you execute it. Right. So this is fairly straightforward. The same thing as we have done. It's very similar, super similar, right? Except the files are organized differently. Since in case of skills, we have this folder, and then skill. In case of commands, it's just one Markdown file. Okay, and now we want to execute this. And one more thing, in order for this to work, okay, I need to copy this thing first, because what we want to do is also, we have this tools object with all the tools that our agent has access to. I want to add this commands tool. So now we have the skill tool and we have execute command tool and all the other tools that we have from the coding agent. Right. And one more thing before we finish, what I want to do is, here. I want to adjust our prompt. I want to make it more obvious for the agent when to what to do with this thing. So I think I lost a bit of the command. Sorry. So I need this. Yeah. So this is what we did before, but also I want to say don't confuse skill and commands. So skills, this is what I told you. And the reason I'm doing this is for models like GPT-4o mini, be more explicit. So smarter models will figure this out because I already described it here. But for models like GPT-4o mini, you have to be more verbose. So that's why I'm adding more instructions, saying don't confuse skills and commands. I explain the difference. And when I say, when you see command, then use the tools to execute the command, right? So now our prompt becomes this. So we have this list and we have this append. And we can also actually include it here, right here, right? And then just append at the end, right? It doesn't really matter in which order we do this. And then I'm going to copy these two things. So this one, let me delete. So we have the runner. The runner has the new instructions, and also we pass this tools object that has the new tool. And let's run. And I want to do this git. Okay, now it executes the command. And now it should generate guess what? I have a super fun idea. Create a magic animal emoji generator. Theme animal, format generator, twist randomly combines animal names with emojis. Yeah, it's not stellar. It's not amazing. Like, of course, if you ask Opus to generate an idea, it will be more entertaining. But this one is fairly simple. Now, I'm not going to try and run parent. I don't know if it will work or not. But yeah, now you know how to implement actually all these things. So that was the whole idea behind this workshop. So we talked about skills, we talked about commands, we talked about how to use them and how to implement them. And next time you use these things in your Claude Code or Open Code or whatever you use, you will know how they work internally. So you will be able to use them better. That's one thing. And another thing, if you are working on implementing the agents yourself, then it's going to be quite helpful. Maybe you'll get some motivation, some ideas from this, and perhaps maybe it will not be necessarily skills for your application, but something similar where you want to use a similar pattern of loading instructions lazily. So instead of like putting all these things in your prompt, you can lazy load them. So I think it's a nice approach. Okay, so let me check if I have more questions. So we're not sending an explicit list of commands in the system prompt, just generic instructions to interpret text as a tool call. I mean, we do send a list of yes, here for skills we do send a list of skills, but for commands no. We might probably do this. Maybe we should. Up to you how we implement this. So if I do this test, the command doesn't exist, so it will try to execute it, and then it will probably report that it's not available, right? So we don't really need to do anything special about this. So in this case, we don't really need to have a list, because in this case, the user kind of wants, the user knows that they want to execute this command, so we don't need to, the agent doesn't need to decide when to use the command because it's explicitly coming from the user, right? While for skills, it has to be discoverable in a way, right? So that's why we need to provide the list of skills, but for commands it's less important. And then, yeah, so this is to your comment, we probably need a handler for unimplemented. Yeah, so it just returns nothing or command not found, right? So I think we're handling it here, command not found. And then it says, yeah, I don't know this command. Okay, so thanks everyone for attending this session. And I want to finish this session by saying a few words about the upcoming course that I have. So if you like the session and you like the style of teaching and you found it useful, you will also find useful the course I'm running. So I'm going to share the link here. So while in the course, we're not going to actually implement skills and commands, we do implement a coding agent in one of the modules as one of the examples, where is the syllabus, but basically like week 4 or 5, we're implementing an agent. So if you enjoyed this and you want to learn more about building agent, so this program, this course is for AI engineers. So not for people who want to use Claude Code, but for people who want to implement tools like Claude Code. So this is what we're going to do in the course. And in addition to defining tools and agents, we're going to spend a lot of time on testing these agents, evaluating these agents, monitoring these agents, and things like that. So if it sounds very interesting, check it out. And I don't see any more questions in the chat. So unless somebody has any questions, we can call it a day and enjoy the rest of the evening. So for me, I'm in Berlin. It's 6 p.m. So for me, it's the end of the day. So I don't see any questions. I'm going to stop sharing my screen so you can see me better. So thanks everyone for attending. It was very lovely to interact with you, to present to you. I really enjoyed preparing for this workshop. I hope you enjoy seeing the content. And we'll have more workshops. So see you around. Bye, everyone.